नमस्कार बच्चों, मेरा नाम धन्या और हम लोग ग्रेड 11 केमिस्ट्री का 4th लेसन स्टार्ट करने वाले हैं जिसका नाम है केमिकल बॉन्डिंग एंड मॉलिक्यूलर स्ट्रक्चर. Okay, and in this lesson we are going to today what we are going to learn is the Lewis approach to chemical bond formation, the concept of ionic bonding, formation of ionic bonding, and the factors affecting the formation of ionic bonding. And also we will discuss about the properties of ionic compounds. Okay, now these are the things that we are going to discuss in today's video. Okay, now this is a very important lesson as far as the competitive exam is concerned. Every year questions are asked from this lesson. Okay, now student, we all know that there are so many elements in the periodic table. All of them do not exist individually except for the noble gases, right? Because they have a stable octet, right? But in case of other elements, they tend to combine with other elements to form compounds, or they exist as molecules, right? Now, when they form molecules or when they form different compounds, there will be attractive forces between the elements to form compounds, or that means the elements that have combined to form compounds, there will be attractive forces between them. Okay, and those attractive forces are called as a chemical bond. Okay, so chemical bond is nothing but the attractive forces which holds the various atoms together. Okay, is called a chemical bond, right? Now, there are various kinds of chemical bonds. Okay, so chemical bond is nothing but the attractive forces that holds the atoms or ions together, right? Now, sharing the whiteboard. Students, chemical bonding we just discussed is the attractive forces that keeps the atoms together in a molecule, right? Now, chemical bonding is of two types. It is intramolecular and intermolecular. Okay, so intramolecular, as the name suggests, it happens within the molecule. Within the molecule. Okay, so within the molecule. Now, in intramolecular, what happens? They keep the atom, these forces of attractions keep the atom together. These are strong forces of attraction. They keep the atom together with the strong bonds. There is strong attractive forces between the atoms that keeps the atom together. Okay, so these are forces of attraction within the molecule. So forces of attraction that keep the atoms together in a molecule. Okay, so these points I can rub because I have combined these 2 points and framed the sentence. Now, these are strong forces. Now, examples of these intramolecular forces or these bonds are ionic, which is a very strong bond. Then we have covalent. Then we have metallic and coordinate bond. Okay, so these are the examples of intramolecular, that means forces of attraction that keep the atom together in a molecule, and these are strong forces. Okay, so this is intra within the molecule. Okay, and these are just strong forces of attraction. Now, intermolecular. Intermolecular means forces of attraction between the molecules. Between the molecules. Okay, these are not that strong. These are weak bonds. Okay, these sometimes these are temporary also. Okay, and these are not very strong as compared to intramolecular bonds. Okay, so examples are van der Waals, forces of attraction, van der Waals forces. Then we have dipole interaction. Also hydrogen bond. Okay, so these are the examples of intermolecular. These are examples of intermolecular bonding, that is forces of attraction between the molecules that keeps the molecule together. Okay, these are not very strong bond as compared to the intramolecular chemical bonding. Okay, so chemical bonding is nothing but forces of attraction that keeps the atoms together or keeps the molecule together in case of intermolecular chemical bonding. Okay, so we have to learn about ionic bonding, covalent bonding, hydrogen bonding. Okay, and the other bonds we will be learning some details about the other bonds as well. Okay, now coming to the next topic. Why do these atoms form bonds or causes of chemical bond formation? Next topic is causes of chemical bond formation. Chemical bond formation. What is the causes? First cause is because the noble gases are stable, they have a stable configuration. They have 8 electrons in their outermost shell, right? So that's the octet rule. Okay. So same way, other elements also try to be stable by forming bonds. So our first reason is to achieve octet. Octet means what kind of configuration it is? Noble gas configuration. To achieve noble gas configuration, which is considered to be a highly stable configuration. Okay, now noble gas configuration is what kind of configuration? Stable configuration. Okay, for example, this is 1s2. S orbital, the capacity is 2, it has achieved that. Okay, except helium or all other gases, all other noble gases have 8 electrons in the outermost shell. For example, neon. Atomic number is 10. 1s2, 2s2, 2p6. So here it is 8 electrons, right? Then I have argon, 1s2, 2s2, 2p6, 3s2, 3p6. This whole thing, 8 electrons. So this is the octet rule. So it is ns2, np6. This is the octet rule. Okay, so this is the traditional definition to achieve the reason. This is a traditional reason, but we have found out some elements of xenon. Okay, xenon is a noble gas, but it combines with oxygen to form oxide, and some other compounds have been discovered for noble gases. So this is the traditional reason. Okay, the actual reason, or the reason that they form bonds, is to lower the energy of the system, or to lower the potential energy of the system. To lower the potential energy of the system. Okay. Any system, if it is at a lower energy, it is considered to be more stable. Okay. So in order to lower the potential energy, they combine. Okay. For whatever leads to lower energy, that form will be more stable. Okay. Now, if I have atom A, this is the nucleus, Na. Make it a bit bigger. Na. I have atom B. Nucleus is Nb. Okay. I have electrons here for atom A is Ea. Electrons for atom B is Eb. So if these two, for these two atoms, atom A and atom B, there can be, for atom A and atom B, if we consider between electron A and electron of B, what kind of forces will be there? Repulsive forces, repulsion. Sorry, I've written the spelling wrong for repulsion. There can be repulsive forces. Similarly, for nucleus A and nucleus B, there can be repulsive forces because both are like charges. But what kind of, between which two particles there will be attraction? Between the nucleus of A and the electrons of B. Nucleus of B, electrons of A. Of course, there will be attraction between electrons of A and nucleus of A. Other than that, okay, here, what kind of forces are there? Attractive forces. Okay, so these are the type of forces that exist in this particular system. Okay. Now, if these two atoms, A and B, they are coming closer to each other, if they come closer to each other, there can be attractive forces between the nucleus of A and the electrons of B, nucleus of B and the electrons of A. And when they reach a distance, an optimum distance, the attractive forces is increasing. Okay, this is an optimum distance. Okay, so this is A and this is B. Suppose this is an optimum distance. Okay, here at this, the attractive forces are maximum and a chemical bond is formed between A and B. Okay, and this optimum distance is called as the bond length. This optimum distance is called the bond length. Now, if these two atoms come more closer to each other, then there can be repulsive forces now between the electrons. Okay, so bond length means is the optimum distance where the force of attraction between A and B is more. If the atoms come closer to each other, the repulsive forces come into play. Okay, so at this optimum distance, at this bond length means the optimum distance where the attractive forces are more or the bond is formed, the potential energy is minimum. The potential energy is minimum at this point where the bond is formed. Bond is nothing but the forces of attraction is maximum. Okay, and this optimum distance is called as the bond length. Okay, so I'll just demonstrate with a graph that is there in your NCERT book. Okay, just share the PowerPoint. So this diagram you must have seen in your NCERT book. This is a graph between potential energy and bond length, right? Now, in this case, if you see, this is the distance r. This is at infinity. For an atom, infinity is not too much of a distance because the atom is very, very small. Now, this is infinity, r infinity. Now here, this is r. R here tends to infinity. Here, infinity is not a very big distance because atom is itself very small. Now, when the distance between the atom, it is reducing. Okay, what is happening to the energy? Energy is also reducing, if you see. Okay, so energy is becoming lesser. Now, at this point, this distance is the optimum distance. This distance is the optimum distance, which is called as bond length. At this optimum distance, what is the energy? The energy, the potential energy is minimum. The potential energy is minimum. So as the atom comes closer, the potential energy is reducing. And at this optimum energy, the potential energy is minimum, or the other way around. When the potential energy is minimum, the atoms are at optimum bond length or optimum distance. And this optimum distance is called as bond length. And the forces of attraction is maximum. Okay, and forces of attraction come into play and they are held by strong forces of attraction. Now, if the atoms come more closer, what is happening to the potential energy? That will increase. That will make the system again unstable. Okay, so bond length is the optimum length. Okay, now, so this diagram is important. Okay, you must have seen it in your NCERT book, right? Now, moving on further. Okay, students, moving on further. To ionic bond. That is the first type of bonding that we will be learning. Okay. Ionic, from the name ionic. Okay. The first type of bond that we are going to learn is ionic bond, which is also called as electrovalent bond. Okay, so in this we will be learning about Lewis dot structure. We will be learning about the conditions for forming electrovalent or ionic bonding, properties of ionic bonding. Okay, now formation. First is formation. How it is formed, or between which species it is formed. Here, it is formed between a metal and a non-metal. There should be a metal, there should be a non-metal. Okay, you must have learned some part of it in your lower grades. Here, the metal will lose electron, non-metal will gain electron. Okay, we have learned in our previous lesson, metallic elements have a tendency to lose electron, non-metallic elements have a tendency to gain electrons. Okay, so the electron that is lost by the metal is gained completely, or there's transfer of electrons, complete transfer of electrons from metal to non-metal. Okay, let's see how. For example, if I take the example of sodium. Sodium, the configuration is 281, it's 11. So it loses one electron to give sodium ion. Okay. And this is in the gaseous state. Okay. Similarly, chlorine, 287. It is short of one electron. It will gain that one electron to give chloride ion. Okay. And there is attraction between the sodium ion and the chloride ion to give you Na plus Cl minus. And this opposite charges attract each other. And these forces of attraction keep them together in a bond, which is called as ionic bond. So electrovalent, that means charges are involved. So basically there is no bond formed, but there is strong forces of attraction between the positive sodium ion and the negative chloride ion. Okay, and both of them in the gaseous form. Now, here, this sodium ion is in the gaseous form, chloride ion is in the gaseous form. Now, you must be thinking, for sodium, after losing one electron, it has attained a stable gas configuration, stable configuration of 2,8. Chloride ion has also attained a stable configuration. Now, you must be thinking, sodium ion is itself stable, chloride ion is itself stable. Then why they need to combine? Okay, why they need to combine? Now, you must have learned that gaseous, they are all in the gaseous state, right? In the gaseous state, the ions are not very stable. But when the sodium ion and chloride ion, they attract each other, they form solid state. Okay, they become solid, and that is highly stable. That is why even though in the gaseous state they have attained the noble gas configuration, because they are in the gaseous state, they are not very stable. So sodium ion attracts the chloride ion to form solid sodium chloride, which is stable. Okay, so here the ionic bond is nothing but the forces of attraction, strong forces of attraction between, electrostatic force of attraction between the oppositely charged ion. Okay, that keep them together in a bond. Okay, now this electrostatic force, this is very strong bond. This is a very strong bond, strong electrostatic force of attraction, because the force that keep the charges together, we have learned this formula, is very strong. And you can see force is inversely proportional to distance. When R is less, force is more. Okay, so ionic bond is a very strong bond. Okay, so it is just the forces of attraction that keeps the ions together in a bond. right? So this was our formation. This was our formation of ionic bonding, right? So we have the metal atom, non-metal atom, complete transfer of electron from the metal to the non-metal to become stable. Okay, and these ions, although they are stable in the gas state, they have attained the stable configuration in the gas state, still because they are in the gas state, they are not very stable. So the oppositely charged ion combine to form the solid compound. Okay, that keep them together, and the oppositely charged ions keep them together in a bond which is called as electrovalent or ionic bonding, which is very, very strong. Okay, moving on further to our next topic, which is called as Lewis dot structure, which is very important. Lewis dot structure. Now, here students, we talked about sodium ion, which has a configuration of 2,8. We talked about chloride ion, which has a configuration of 2,8,8. Now, sodium atom has given one electron to chlorine, and it became chloride ion, right? In Lewis dot structure, we have sodium with a positive charge, okay? And we have chlorine. The electrons of chlorine I represent with a dot. 7 electron of chlorine atom, 1, 2, 3, 4, 5, 6, 7, and 1 electron that it got from sodium, and representing with a dot with a negative sign. And this electron is from, you don't have to write that, I'm just denoting it so that you can understand, from sodium, right? This is one way of representing the Lewis structure, or you can also represent like this: sodium and chlorine. 1, 2, 3, 4, 5, 6, 7, like this. You can either show the process, or after the process has happened, what do you get? You can show in either way. You can represent either way. Okay. So this was the Lewis dot structure of sodium chloride. Okay. So similarly, so this was the first example. So similarly, we can show the electron dot structure for magnesium chloride also. Right. Now, for magnesium chloride, the formula is MgCl2. So magnesium is, it's 2,8,2. It is losing 2 electron to form magnesium 2 plus ion, all in the gaseous form. And chlorine, there are 2 chlorine you can see here. In the gaseous form, it is gaining 2 electrons. 2 chlorine atoms are gaining 1 each electron to give you 2 chloride ion, 2, 8, 7. Each of them needs 1 more electron, right? So I draw like this: magnesium 2 plus Okay, so there are two ways of drawing. Either you can show what has happened after the electrons are given by magnesium to chlorine, or the process that is happening. So this is chlorine. So this is chlorine. So chlorine has 7, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and the one electron that it obtained from magnesium, I'm showing with a cross, and each chloride ion has a negative charge because it has received one electron. So either you can show this way, or you can show the actual process, what's happening. So in either case, you will only show the valence shell electrons. So magnesium has 2 electrons that it is ready to give to each of the chloride ion. So I have here chlorine, here chlorine, 1, 2, 3, 4, 5, 6, and 7. One electron goes to chlorine atom to form chloride ion. Again, 1, 2, 3, 4, 5, 6, 7. One electron from magnesium comes to chlorine to form chloride ion. So either way you can show the electron dot diagram. Either you can show how they look like after the process has happened, or the process itself. Okay, so this is the electron dot diagram. Okay, more we will practice when we will do the past paper questions. Okay, so coming to the next topic, which is called as electrovalency. Okay, electrovalency. The meaning of electrovalency. So electrovalency means the number of electrons that is given by the metal or received by the non-metal during the formation of ionic bond. So in electrovalency, we always talk about the magnitude. We don't put the sign. Okay. So the number of electrons given by whom? Given by the metal, or taken by non-metal. That's understood. During the formation of ionic bond. And it's always positive. We always take the magnitude. Okay. Suppose if I have group 1. I have group electrovalency. Suppose if it is group 1, okay, group 1 means the elements are lithium, sodium, potassium, rubidium, okay. So all of them, they have 1 electron in the outermost shell, so they readily donate that 1 electron, and the electrovalency is 1. Okay, suppose if I have group 2, group 2 is beryllium, magnesium, calcium, strontium, okay. They readily donate the 2 electrons, and the electrovalency is 2. Now, group 3 to group 12 is the D block element, okay. So for now, please remember that they have variable valencies. Variable valency. For example, when we were doing the lesson on periodic classification, we talked about iron 2 plus, iron 3 plus. So see, it doesn't have a fixed valency. It has more than one valency, variable valency. Similarly, chromium 3 plus, chromium 4 plus, or 2 plus. Okay, so it has variable valencies. So group 13 to 12, the D block, group 3 to group 12, they have variable electrovalency. It's not fixed. It depends upon the compound that is formed. So variable electrovalency. Okay, so group 3 to group 12. Okay. Now, coming to group 13, we have aluminium, gallium, all those elements. They readily give 3 electrons. Okay. Then I have group 14. It consists of carbon, that group. Okay, silicon, germanium. Now this I'll denote in red because group 14, like carbon, silicon, germanium, they are into sharing. What do? They share the electrons. When we do covalent bonding, we will be talking about these elements. Okay, so they don't give or take, they share electrons. Now, moving on further, group 15. Group 15 is nitrogen, phosphorus, arsenic, nitrogen. Okay, so they have 5 electrons in the outermost shell, so they need 3 electrons. So they accept 3 electrons. Okay, but we write the electrovalency positive only. This is arsenic. Then I have group 16, the oxygen group. I have oxygen, sulfur, selenium, tellurium. They accept 4 electrons because they are 4 electrons short. So they accept 4 electrons. Then I have group 17, the halogen group, fluorine, so I have the halogens, fluorine, chlorine, bromine, iodine. They are 1 short of electrons. Okay, so short of 1 electrons. They are short of 1 electron to become stable, so they accept 1 electron. And group 18 is the noble gases. They don't need electrons. They are stable themselves. So this is about the electrovalency, which is the number of electrons given or taken, but we represent it in positive way. Okay. Okay, students, the next topic is favorable conditions or the energy terms that are involved in the formation of ionic bond. Okay, so in ionic bond, you already know there should be a metal that loses the electron to form metal ion and non-metal that accepts an electron to form a non-metal ion, to form a negative ion. Yes. Now, the first one we talk about metal. Okay. And the metal in the gaseous form, it is losing electron to form metal ion. And the amount of energy needed to remove the electron from the gaseous metal atom to form metal ion is called the ionization. Ionization energy, we already learned it in the previous video or previous lesson. Ionization energy. And if less energy is provided, more better. Yes. Second one is non-metal. So the lesser the ionization energy or the energy given to remove the electron, it is better. Okay. Then next is the non-metal. Suppose a non-metal X, it is gaining 1 electron. Non-metal in the gaseous state is, we are talking about non-metal. To form non-metal ion. Okay. And we have some amount of energy released, which is called as electron affinity. So electron affinity is the energy released when the non-metal atom or when any element gains an electron to form in the gaseous state, gains an electron to form the ion. And electron affinity is the amount of energy released. It is the amount of energy released. Electron affinity, right? Now, if for the compound to become more stable, if more amount of energy is released, more energy released, the compound formed is more stable. Okay, so when we combine, we have, so for a compound to be stable, if ionization energy is less and electron affinity is more, then the compound formed is very stable. So we have metal ion combining with non-metal ion to form solid ionic compound, and when they combine together to form the ionic compound, an energy is released which is called as lattice energy. Lattice energy. Okay. So when the gaseous cation combines with the gaseous anion to form an ionic compound, the energy is released, which is called as lattice energy. Now, what is lattice energy? When 1 mole of the ionic compound is formed from the ions. Calculation is there. We will be learning that in the next video. So lattice energy is what? When 1 mole or the energy released when 1 mole of an ionic compound is formed from ions. Now, students, always remember whenever energy is released, more the amount of energy released, the compound formed is more stable. Okay, so calculation of lattice energy is important. That a lot of questions is asked from that part. We will be doing that in the next video. Okay, so more the lattice energy, more stronger is the compound, more stable is the compound, because suppose this for the formation of this mx, a lot of energy is released. So lattice energy is high. So this compound formed is very stable. And to break this bond, to keep these or to separate these ions, you have to put in a lot of energy. Okay, so whenever in a system or whenever in a reaction, when a lot of energy is released, it leads to a stable compound. Okay, so students, we just discussed about the conditions, favorable conditions for ionic bond. That is, what all are the energies involved. We first said that when the metal is losing an electron, some energy has to be provided. That is called the ionization energy. Lesser the amount of energy provided, the system is more stable. Okay, second, for non-metal, it needs to gain an electron to form non-metal ion. And in this process, the energy is released, and that is electron affinity, is the amount of energy released when 1 mole of gaseous atom accepts an electron. Now, whenever energy is released, if more amount of energy is released, the system is more stable. So more amount of electron affinity, the system is more stable. Now these metal cation, or the cation and the anion combine to give you ionic compound, and in that process also energy is released, which is called as lattice energy, which is nothing but the energy released when 1 mole of ionic compound is formed from the ions. And whenever energy is released, if it is more, the compound formed is more stable. Okay, more stronger the bond, because you have to put in that much amount of energy to separate them into constituent ions. Okay, so calculation of lattice energy, very important, which we would be doing in our next video. Okay, now moving on further, students. I hope till here it is clear. Next one is which is more metallic, or which is more ionic rather. Okay. Which is more ionic? If a set of compound is given, if they are asking you which is more ionic. Okay, you know ionic bond is formed between a metal and a non-metal. Non-metal. Okay, non-metal. Right. Now suppose if I have a set of compounds like sodium fluoride, sodium chloride, sodium bromide, sodium iodide. Okay, so which is more ionic, or which bond is more stronger? In here, the cations are the same, sodium. Right. Now, the anion is in group 7, fluorine, chlorine, bromine, and iodine. Down the group, what is happening to the non-metallic character? Non-metal character decreases, right? So fluorine is more non-metallic, more non-metallic. Iodine is least non-metallic. Non-metallic nature is very, very less compared to the others for iodine. And ionic bond is very strong when it is more metallic metal and a more stronger non-metallic. Sorry, an ionic bond is stronger when metal has more metallic character and non-metal has more non-metallic nature. So here the cation is the same, sodium, but what about the anion? Fluorine is more non-metallic. See, up the group, it is more non-metallic. So fluorine is more non-metallic. So definitely sodium fluoride is more ionic compared to sodium chloride, compared to sodium bromide, and compared to sodium iodide. Okay. So if the metal is the same, you go for non-metal and check which is having more non-metallic character. Down the group, non-metallic nature decreases. So fluorine is more non-metallic. So the bond formed between sodium and fluorine will be more ionic compared to the others. Okay, let's cite one more example where you have, where I'm changing the metal. Lithium chloride, sodium chloride, sodium chloride, potassium chloride, and rubidium chloride. In here, the non-metal is the same, chlorine. So we need to check the metallic character of the group 1 elements. So I have lithium, sodium, potassium, rubidium. What is happening to the metallic character down the group? It is becoming more metallic. So who is having more metallic character here, rubidium. So the bond formed between rubidium and fluorine is more stronger than the rest of it. So this is how you decide. And lithium chloride, because it is having the least metallic character, lithium chloride will be more of covalent nature. Okay, and rubidium chloride is the stronger ionic compound, rubidium chloride, this one. Okay, so this was about the ionic nature or the strength of the ionic character if the set of compounds are given and you need to choose which is more ionic. Okay, so go with the compound which has more metallic and non-metallic character or nature. Then we have the properties of ionic compound. Okay, now physical state. They have a lattice structure. They have a lattice structure is nothing but a 3D structure. Okay, and they are solid at room temperature. Okay, so I'll just give an example of a lattice structure for sodium chloride. Okay, so this is the lattice structure of sodium chloride or rock salt. You can see it's a three-dimensional shape. Okay, and the ionic compounds are solids at room temperature. In this, each sodium is surrounded by six chloride. Each chloride is surrounded by six sodium and vice versa. Okay. Then we have so more about lattice and lattice energy we will be discussing in the next video. So ionic compounds are solids at room temperature. In fact, they have a three-dimensional lattice structure. Okay. Now we already discussed that the ionic bond is a very strong bond. So electrostatic force of attraction between the oppositely charged ions is very strong. So you need to provide a lot of energy to break apart. So they have high melting and boiling point because of the strong electrostatic force of attraction. Between whom? Between the oppositely charged ions. Okay. Now coming to the third and very important property is conductivity. Now, conductivity, they are poor conductors or bad conductors when they are in the solid state. Because this sodium chloride or the ionic compounds, the oppositely charged ions are held by strong forces of attraction. There are no free ions. No free ions. There should be some medium to conduct, right? So there are no free ions to conduct. In which state? This is the first part, solid state. Okay, so there should be some medium to conduct, but in solid state, because the ions are held by strong forces of attraction, the ions are not free to move. In which state? Solid state. So they are poor conductors or bad conductors. In which state? Solid state. Okay, but in molten state, molten state means in the liquid form, when you melt it. Molten means when you melt it, the ions become free to move. These ions become free to move, and then they are good conductors. In which state? Molten state, when the ions are free. Molten means when you melt it, ions are free. Third is when you dissolve in water, in aqueous solution. In aqueous solution, this water reduces I'm just taking one example of sodium chloride, okay? Water reduces the force of attraction between them. So water reduces the forces of attraction between the ions. And so the ions become free to move and they are good conductors. So in fact, they are poor conductors when they are in solid state, but become good conductors if you melt them or if they are in the aqueous state. Why? Because of the free ions present. Okay. Here, when you dissolve in water, water reduces the force of attraction. That's the dielectric property of water. Okay. And along with this, we learned that ionic compounds, they are soluble in water. Okay, they are soluble in water. Now, coming to the next property, which is third property, right? Fourth property. Fourth property, isomorphism. Isomorphism. What is this? Isomorphism. Isomorphism is the property where two different compounds share the same (3D) or crystal 3D structure. Don't worry about this. You have to learn the conditions. This is a property where you have to learn two conditions for any two compounds to show isomorphism. Okay, suppose this is not for single atom. Here we compare two compounds together. Okay, for any compound to show isomorphism, they should have similar formula. Don't worry, I'll show with an example. They should have similar formula, not same, similar. And also size of cation and anion should be nearly same. Should be nearly same, not same, nearly same. Okay. These are the two conditions for any two compounds to show isomorphism. Okay. So isomorphism means two different compounds, they share the same crystal 3D structure. For example, if I take sodium fluoride and magnesium oxide. Okay. Now here, sodium and magnesium. Sodium and magnesium, they are in the same period. So they have, the size is not same, but similar. So size of cations are similar because they are in the same period. It's a gradual increase, right? So it's not a big jump. So sodium and magnesium have similar size. Now, fluorine and oxygen, they are in also in the same period. So cation size also similar. Anion. This is anion, right? So anion size also similar. So these two compounds show isomorphism. They have similar formula also. Similar formula. That's the first condition. And the second condition, size of the cations should be similar size and anion should have a similar size. Okay, not the same, but similar, not a huge difference. Okay, if I take an example of, for example, sodium chloride and potassium chloride. Here, the anion is same, okay, fine, but you can see sodium and potassium, they are in two different groups. So that means there is a lot of difference in the size. So they don't show isomorphism, although they have similar formula. Okay. So this is an example of isomorphism. Okay. So you have to check the period, which period. If it is the same period, that means they have the similar size. And you have to check the formula if it is similar formula. Okay, not the same, of course, because it may not be the same compound. It is different compounds, right? So similar formula and size of cation and anion should be similar. Coming to one last property, which is the type of reaction. Whether it is fast reaction or more about this, we will be learning in chemical kinetics, type of reaction. That means ionic compounds formation involve the reaction of ions, which is very, very fast. Ion reactions are very fast, so it is difficult to study that. These kinds of reaction, as the speed is very, very fast. Okay, for example, if I take sodium chloride in the aqueous form is reacting with silver nitrate in the aqueous form, it will give you silver chloride, which is a precipitate, white precipitate, plus sodium nitrate. Here it involves the formation of precipitate, right? All precipitation reactions are very, very fast. But the covalent compound reactions are very slow. Ionic compound, they react very fast. Okay, so it is very, very difficult to study. Right? So, we have also the percentage of covalent character. We have studied before also all the ionic compounds, it is not 100% ionic. There might be certain percentage of covalent character. Similarly, covalent compound may not be 100% covalent. There may be certain percentage of ionic character. So all those we will learn in the next video about Fajan's rule. Also, we will be learning how to calculate the lattice energy in the next video. Okay, so students, today we discussed about the ionic compounds, the conditions, the properties. Okay, so all those energy terms that are involved there. Okay, so in the next video we will be learning about lattice energy, the calculations. Okay, so that's all for today. Students, thank you. Have a great day.